Actually, I skipped one, didn't I? Let's start with, can anybody tell me what natural numbers, a set of natural numbers are? You might not know. Maybe somebody saw it in their book, but. Okay, natural numbers are sometimes called the counting numbers. 1, 2, 3, 4, goes forever. Okay, starts at 1, goes forever. Whole numbers. Starts with 0. 0 kind of looks like a hole, so maybe that can help you remember. Whole means complete, but if you spell it with an H, it means like a hole in the ground. Anyway, it's 0, 1, 2, 3, 4, it goes forever. So they're almost the exact same thing. The only difference is whole numbers have a 0. 0 is kind of important. After that comes integers. Maybe I should be using that symbol. Do that. Anybody know what integers are? Well, I know you've used them before. You might not remember the name of them. But, dot, dot, dot. So it goes forever towards negative infinity, forever towards positive infinity. So it includes negatives, positives, 0, kind of all the numbers on a normal number line. What's not included in integers? What is not included in this list? Decimals. Fractions, which are kind of the same thing as decimals. Decimals, fractions, there you go. That's pretty much it. Almost it. Integers. Then after that comes rationals. Well, if you guys didn't remember what integers are, I'm guessing we'll definitely not remember what rationals are. This one's a little trickier. Rationals are anything that can be written, well, the technical definition's a little bit tricky. Anything that can be written as a normal fraction, A over B, where A and B are integers. So anything that can be written as a normal fraction. However, okay, so for example, would 3 be rational? Okay, yes, because even though it's not written as a fraction, it can be written as a fraction if I do what? Put it over 1. So really, all these numbers up here, if I put them over 1, they stay the same. So all these integers are rationals. But integers don't include like 3 over 2 or negative 7 over 5, but these are also rational. So rationals include all these, but a lot more. Or if I write some decimals, 1.3 or 0.3 repeating. Does anybody know what 0.3? Because okay, this is 1 3/10. You guys remember that? And I could change it to an improper fraction so it looks more like this by multiplying by 1 and adding 3. 10 times 1 plus 3 is 13/10. So anyway, decimals, fractions, they're pretty much all rationals. Does anybody know what 0.3 repeating is as a fraction? Might not. It turns out it's 1/3. And this is just an example, but it turns out so you guys remember what this line means? It means, yeah, it goes forever. 3, 3, 3, 3, 3. If you plug in 1 divided by 3 in your calculator, that's what it'll spit out. 3, 3, 3, 3, 3, 3. If you did 2 divided by 3, it's 0.66666 forever. Turns out repeating decimals are always fractions. They can always be turned in. So these are rational also. Okay, notice that the natural set is all included in the whole set. You guys see that? So you can say naturals are a subset of the wholes. Notice that all the whole numbers are inside the integers right there. So you can say whole numbers are a subset of integers, which means natural numbers are also a subset of integers. And we already talked about this, but all the integers are also rationals. So you guys know what Russian nesting dolls are? All these fit inside these, fit inside these, fit inside these. So really everything that I wrote on the board is rational. But if you want to be more specific, like graph the integers on a number line. So sometimes we use the word integers. Or, you know, what whole numbers would work in this problem. So sometimes we just use these other words. Yeah, honestly, I don't think the books ever use the natural numbers as, because usually you want the zeros. But anyway, so all those are rationals. So if all those are rationals, is there such a thing as irrational? You guys know what rational means outside of math? Like just normal, everyday language?
Rational.
Logical, yeah. It means it makes sense. So these numbers kind of make sense to us. So irrational kind of means weird. Not as easy to understand. Does anybody want to guess?
Pi.
Pi is the most popular irrational. What's weird about pi?
None of the numbers are repeating.
Right. It goes forever and it never repeats. Remember I said up here 0.3 repeating is like 1/3. So repeatings are kind of normal actually. But pi is weird. The biggest computer in the world, smartest computer in the world, can't find the end of pi. And as far as we can tell, it never repeats. Do you guys know where pi comes from? I knew there was going to be a joke with that. Pi is more of a geometry thing, but it's the number of diameters, this is a diameter, that it takes to wrap around the circle that it's in. 3.141, whatever. Okay? Every time. No matter what your circle is, the diameter takes a little bit more than 3 of them to go around it. And it's used to find the area of circles and how big it is, the circumference, that stuff. I don't suppose anybody knows another irrational, do you? Square root of lots of things. 5 is another. If you ever plug like what does square root mean?
The number times.
No, it's what times it's, that's 5 squared is 25. So this is, square is kind of the opposite of square root. This means what times itself equals 5. 2 times 2 is 4. 3 times 3 is 9. So this is probably 4.2 or something. But it's actually an infinite non-repeating decimal. You can plug it in just like pi. So it's weird. It's really weird. And actually, most square roots are really weird. Square root of, how about like square root of 9? What's that equal to? 3. So since it's just 3, it actually goes, square root of 9 would go up here in the rationals. Okay, all those things up there kind of off by themselves. But how about square root of 10? Where should that go?
Up there.
What times itself equals 10? 3 times 3 is 9. It's not 5 times 5, right? 3 times 3 is 9. So this is probably about 3.1, 3.2. 4 times 4 is 16. So it's actually irrational too. Just because it can be divided by 2 doesn't mean it has a square root. Different things. Anyways, so this kind of, all these numbers combined make of all the numbers you've ever seen. All these kind of go together in the rationals group, and the leftovers are called irrationals. Everything put together, rationals and irrationals, are called real numbers. Now, if all these are called real numbers, that begs the question, what question should follow that?
What's not real?
Is there a not real number? The answer is yes. But that's more like an Algebra 2 thing. So yeah, it's called imaginary. This is all the numbers, kinds of numbers you'll see this year. Yeah. All right. Got it? I'm on our home page. A lot of what we're doing today is like number lines, a lot of it's kind of easy. A few trick questions, so we do have to be careful. But, yeah, you guys saw the assignment up there. Let's talk about graphing a little bit on a number line. Well, you guys last year, remember those XY coordinate plane graphs? That's if you want to graph an ordered pair, which that's not today. That's like, I don't remember what chapter that is, but that's not this chapter. We're just graphing one number. So how do you graph one number on a number line?
Find y or x.
Okay, you're not going to have to make a giant number line. So if I want to graph 3, okay, we'll just keep it simple. Let's just go 2, 3, 4. Okay, but how do I show that I want to put 3 on the graph? How do I actually just put a dot right there? So, yeah. This is called a number line. It's called a horizontal number line because on a few of them they're going to ask you to draw a vertical number line. You guys think of where in real life, like where a vertical number line would be? Altitude. Anything else? Thermometers. Those were the 2 examples I thought of. Maybe there are probably others. Well, I mean, you could do anything vertical, but there's nothing especially vertical about money. You could do it on a This kind of makes me think of a football field. That's kind of how football fields are laid out. Anyways, let's do this. Where would, if I wanted to graph, let's say 1 2/3 on this line, where would it go? Whoops, not what I was thinking there. Okay, where would 1 2/3 be? East.
It would be like right below the 2.
Yeah, pretty close to the 2. So how do we figure it out? Well, 1 2/3 means if you ate 1 2/3 cookies, that means you ate a whole cookie, and then you ate most, like the other cookie split into 3, right? And you ate 2 of those, so you ate most of the rest of the second cookie. So I guess in your head you kind of split this up into 3, and then you go 2/3 of the way, so that would be like right there. Now you don't have to draw those little lines, I'm just giving you a visual. I'm not going to be like, it has to be perfect, I'm just going to be, it has to be close. So if you did put it closer to 1 than 2, I probably counted wrong. So it should definitely be, that's closer to 2 than it's 1. Okay, and then once you throw the negatives in, okay, how about negative 3/4? Where would that be? Right. So negatives kind of freak people out. Just think, where would positive 3/4 be?
Right below.
Okay, it's like, there's 1. 3/4 is less than 1, right?
Yeah.
So if you split this up into 4 steps, 1, 2, 3, 4, it'd be 3/4, 75% of the way there, kind of close to the top. So where would negative 3/4 be? Just kind of a mirror image. Instead of close to 1, it would be close to -1. So I shouldn't have put that dot up there because I really just wanted to graph that. Just put the negative version. So if you get confused, just think of what it should look like positive and then just flip it upside down. Okay. They probably, I couldn't remember. Did they do, yeah, they did a couple mixed numbers or impropers. So what if I did 4/3 instead?
That would be right above the 1, right?
Yeah, do you guys remember how to change 4/3 into a mixed number? This is improper because the number on top's bigger. What? Divide, yeah, it's basically 4 divided by 3, and that goes in once with the remainder of 1. So the remainder just goes over the denominator, so it's 1 1/3. Okay, do you guys have your calculators yet? Anybody need to borrow a calculator? Let's play a little, learn how to use your calculator game here. Maybe you guys know how to do this already. Does everybody know where their fraction button is? Jaden, you might want to borrow a calculator for this part. That does have a fraction thing, but it's kind of a pain in the rear.
Because I thought it was cool. Get $100.
I want you all to try and plug in 4/3 as a fraction. Do you need a calculator? Okay, Jaden, can you hand that green box up here? It's kind of hard for me to show you because everybody's got different calculators probably, but
This is the one
does anybody not know where their fraction button is? I just meant 3.
Oh.
Did you grab one?
I'm stealing hers. She ran off.
Okay, let's go.
That one right here.
This is the fraction button right in the bottom right corner left.
Yes.
Oh, they were pressing it first.
Anybody else? Okay. If you can borrow this for a second. If you have a TI, Texas Instruments thing, they look a little bit, some of them look different than this, that's Texas Instruments. It looks like ABC is a fraction button. So you would hit that between the 4 and the 3. You'd hit 4 fraction button 3. Everybody think they got it? Yeah, okay, if you have a Casio, it looks like a little blank fraction right there. So on Casios, you hit 4 and then you have to hit the arrow buttons to move around in the fraction. So I hit down 3, and you'd have to arrow to get out of it if you wanted to get out of it. Yeah. 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 That's a little weird, but maybe it's right. Yeah, that's good. So yours is right there. So you just hit 4. That's 4. Okay. What I want to do is, let's try and change that on your calculator to a mixed number. So, let's start with the Texas Instruments again. So on this one, the ABC is a mixed number. Oh, hold on. Actually, let me see, make sure. 4/3. Okay, actually on this one, I hit 4/3 equals and I just spat it out. So I know that's kind of probably a whole see on the, you got a Casio?
No, I haven't seen that. I know, I think I do it here.
Bro, what?
On the Casios, there's a SD button above the delete button, right there. And above the SD button, it says ABC, arrow, DC. That means it's changing from mixed to improper, or improper to mixed. So once you enter 430, so if it's yellow, you have to hit the shift button. See how the shift is yellow up here? Texas Instruments have this sometimes too, the shift button. Whoops. Anyway, change it to 1 and 1 third. Do you guys figure it out? Oh, you just figured it out?
Found it, you have to press
That's the
this.
decimal version. So if you just hit that button, it changes. But if you want the yellow thing or the changing
What is that supposed to be? I pressed that one.
I don't know. Looks like it's about, that's just changed the form of the answer, looks like, from fraction, that's. Well, that's what the blue means, that's me.
I realized I could press that, but I was.
Fraction or answer. It's kind of like it's shift. Let's see, on this one. Possible. You guys might go Casios, actually.
Press the number on the bottom and then back it up, and then it gets fine.
New Balance?
How do you Paxton? Paxton, please bring my shoes up.
I don't know how you managed to do that, but that was kind of cool.
Yeah, I'm not sure it's gonna do it. If it does, I would try and get it.
It's like,
Well, I thought it was
I was trying to change it to this number, not this one. But that looks like probably okay, so
yeah.
did you put in the 4/3 already?
I never did.
So the SD thing goes like but if you hit shift, it doesn't go.
I don't either. I've tried so hard. So I have a question.
Anyway, there's a lot of tricks you can learn as we go, but the reason I want you guys to get your own calculator, these are probably about $10. These are probably about $20, and these are a little bit nicer. The black ones that I gave out, probably about $15. But you can get familiar with that calculator. You don't have to worry about sharing it with other people. And eventually, when you take the ACT and go to college, you'll know what you're doing. So we'll learn some tricks as we go. Okay, one of the actually, we probably chatted enough for now. Let's go ahead and turn to page 10 if you haven't yet. Everybody did get the bell work down on that page, right?
Yeah.
Okay, because I will be looking for that on Monday. Let's go ahead and last year well, you were in 7th grade. You guys were in 7th grade. Pre-algebra, I can't remember. This math book has the odd answers in the back. A lot of times I will just do the odds with you, not all the time, but probably most of the time. I'll do the odds with you just to help, and then I'll let you guys do the evens by yourself. But if you ever do an odd and you want to check your answer, it is in the back. So on number 1, it says graph each point on a horizontal number line. Okay, it's A is 4 and B is -3. So that means my number line needs to go from -4, wait, was it -3? Okay, well, whatever. It needs to go from -3 to 4. Page 10, number 1. Okay, it says A is 4. How do I graph that? We already talked about this. Put a dot at 4. If they give you a letter, you can just put the letter floating up by the dot. And it says B is -3. 1 is not a trick question. So I'm going to put a dot at -3, put a little B floating up there. Pretty much all of chapter 1 is pretty straightforward, except for the last lesson, which is exponents, and it is tricky. It'll be new for you guys. Okay, now I'm going to jump to number 3, which means there's a couple ways you could do this. You could do all your odds on the front, the evens on the back, or you could just leave space for the evens, however you want to do it. But I'm jumping to number 3. Okay, number 3 says -1.3 and 0.4. How far back should I go on the number line? Like, what should be my small number, at least? What is less than -1.3? What integer? -2. Right? -1.3 is somewhere between -1 and -2. So my number line should probably go back to -2. And what's bigger than 0.4? 1. So it should go up to at least 1. Okay, so this one, potentially you could actually miss it. It's hard to imagine how you can miss number 1, but number 3 people could miss. Where is -1.3 at? .3 means 3/10. So is that going to be closer to -1 or -2?
-1.
Yeah, it's like 3/10 of the way to -2. So it's still kind of close to -1. And that is a E on that one. All right, and then where is 0.4?
Really close to 0.
Is it
On the right side.
closer to 0? Yeah, it's pretty close to a half, right? Because 0.5 is exactly in the middle. So I'm just going to put it barely to the left of the middle, and that's an F, right? Okay, number 5 says a vertical number line. What did vertical mean again? Up and down. It's really not changing anything, but okay, the lowest number is -25, and the biggest is 40. So where should maybe I start my graph at?
40.
Well, starting low. Yeah, it has to go up to at least 40. Now these are big numbers. Should I mark out like -25, -24, -23, all the way to 40?
No.
What should I do?
15.
Count by 5s, probably.
15.
I'll go ahead and put. So what's less than -25? -30. Okay. I'll go ahead and go below. If you put -25 at the bottom, I wouldn't count it wrong, but I don't know if I left myself enough room. I gotta go all the way up to 40. So I'm gonna change that.
15.
Counting by 15s is weird.
Exactly.
So we're doing
Easton.
Okay, I'll count by 10s. That'll probably be easy.
but we keep it.
Yes, you just go to 30, -30. Put it halfway between.
That's still gonna take a lot of room, isn't it?
Fine.
Fail. Okay, where is negative 25 gonna be?
Like halfway between -30 and
Right, 25 is exactly halfway between 20 and 30, so negative would be halfway between negative 20 and negative 30. And that letter was I. And then 40 is just up here. I'm guessing that's a J, right?
Oh, no.
Just the other way.
40 was an I.
Oh,
25 was a J.
okay. Darn it. Number 7, where is negative 3 halves at? What is negative 3 halves equal to?
Almost 1. Wait.
No.
Almost 1.
So,
Negative 1.
well, I'd say no to that too. What's 3 divided by 2?
3 over 2. Oh.
What's 3 divided by 2? 1.5. So it's negative 1.5. So it's not almost negative 1, it's,
Almost.
What?
No,
it's going to be between what two numbers?
Negative 1 and negative.
Negative 1, negative 2. So I'm going to make my graph go down to negative 2, and then how high do I need to go? What's bigger than 3/4? 1. That'll be big enough. So negative 1.5, just like 1.5 would be exactly between 1 and 2, negative 1.5 is exactly in the middle of negative 1 and negative 2. M. And then we kind of talked about 3/4, didn't we? Most of the way up to 1 on one of our examples. Mostly to 1. Okay, number 9. These are going to go much faster after we're done with the graphing. I'm not going to do all these odds with you. I'll do a couple. If I remember correctly, this section 9 through 17 is where people usually miss a couple problems. So be careful. If you want to ask questions, feel free. This number 9 is not a trick question. It says state the coordinate of each point. What does coordinate mean?
Where is that?
Right, it's a number that tells you the location. So number 9, where is R at?
Negative
1, not a trick question. 9 is not the problem that people miss. I think the problem people missed was maybe 16, 17 or something like that. Problems, I should say. Well, 17 is an odd. I'll leave you 16 as a challenge, but let's look at 17. So these don't take any space. They're just a little tiny answer. 17 says, where is Z at? Okay, be careful. You got to look careful. This is a trick question. You have to look carefully at the graph. It's not quite like the graphs I drew. What's different about it?
Oh, it's
Oh.
No, not flipped.
Oh, wait. It's like
1 1/3.
It's like 1 and 3.
Yes. Each little mark is only counting a unit, half a step, right?
So
It's not.
halfway to halfway.
so it's 1.
Yeah, what's between 1.5 and 1? 1 and 1/4. So 16 is tricky like that too. I'll let you guys try. Number 18 says state the opposite. What's opposite mean?
The opposite of
What's the opposite of 5?
negative
What's the opposite of -7?
positive.
Okay, easy peasy. 22. Actually, people are gonna. I'm guessing a couple people are gonna miss these, even though they're still easy. What does absolute value do to a number?
Makes it positive.
Make it positive.
Okay, what's the absolute value of -5? What's the absolute value of 5?
5.
Nobody fell for it. Okay, yeah, it doesn't mean opposite, it means positive. The technical definition is how far is that number from 0? The answer is 5 for both of those. So,
Wait for
I just made those up, it's not a question in the book. So do not make 18 through 25 harder than it needs to be. Okay, on 27, so absolute values, they kind of work like parentheses. You do inside first, and then whatever is inside becomes positive. So on 27, you subtract like normal, and then whatever comes out of that, what's 341 minus 26? It's like 315. You can use your calculator, I don't care. 315, what's the absolute value of 315? 315. So it didn't actually do anything on that problem. But on 30, notice how each number is an absolute value. So what do we actually need to do on 30? 9 plus 4. Absolute value first, so it's just 9 plus 4. But you actually have to answer that. That's all you do. Yeah. Okay, we are actually going to 36. 35 and 36 says a segment has endpoints with the given coordinates. So they're talking about like a number line. So they're saying on a number line on 35, there's segments with endpoints at 12 and 22. You guys know what they mean by segments? It's just a little piece of a line. So, you know, wherever 12 and 22, there's a little line segment running between those two. Okay, this was our bell work question. The first question is find the length of the segment. How did we do that in the bell work? Subtract. Just do the big one minus the small one. What if this had been a -12?
it would be further.
You still subtract. It would be farther, but you still subtract 22 minus -12, which kind of makes it into a, don't do that. This is not the actual problem, so don't do that. How far is it from 22 to 12?
11.
Just 10. Okay, and then the second question, there's two questions on this part. Find the midpoint. Now we didn't talk about this.
Is that the middle?
Middle. So what's the coordinates of the midpoint? No.
Or like, oh, the number between 17.
Okay, there's two ways to do it. What Easton did was, he said it's 10 across, so you only want to go 5 across to get to here. So he did 12 plus 5. Can anybody think of another way to do it? How do we find a number that's, yeah.
Take your answer and divide by 2.
Well, that's part of it. He took 10 divided by 2 is 5, but then you'd have to add 5 to 12 to get to there. The other way you can do it, and this is probably the easier way if you don't have this number, is average. Average finds a number in the middle of two other numbers. So you guys remember how to average two numbers?
Adding them up and dividing by the times
Right.
10.
Adding the numbers together and dividing by the number of numbers. In this case, there's only 2 numbers. So that would also give you the answer. Either way, you get 34 divided, you should get the same answer. 17. Alright. You guys go ahead and work on that. This is due on Monday. You still got 9 minutes, 10 minutes.
Wait, did we get it at 40?
Well, maybe you're right, actually. Yeah. Okay, we don't have much time. Sorry. Talk to me. This won't take very long at all.
That's